Hello students, we have taken this illustration to understand the concept of distance of closest approach using the concept of relative velocity. Let us look into the question. The question states a ship A is moving westwards. So ship A is there which is moving westwards with a speed of 10 kilometers per hour, and then there is another ship B which is a south 100 kilometers south of A is moving northwards with a speed of 10 kilometers per hour. The time after which the distance becomes shortest. So he's asking us what is the time after which the distance will become shortest. We can also calculate the shortest distance, but in this problem it is asked we need to calculate the time after which the distance becomes shortest. So let us quickly pictorially represent the situation. This is north, this is south, this is west, and this is east. So he's telling that a ship A, let me consider it as say 1, and ship B, let me consider it as 2. So let me consider ship A is moving westward. Let me consider it to be at the origin. I'll show it over here. Ship 1 is moving westward with how much speed? It is given as 10 kilometers per hour. And another ship B is there, which is 100 kilometers south of A. That means if ship 1 is over here, ship A, 100 kilometers south of A. South of A will be in this direction, isn't it? South of ship 1 or ship A, 100 kilometer. There's another ship B, and that is moving in which direction? Towards north. North is in this direction. V2. V2 is equal to 10 kilometers per hour. The time after which the distance becomes shortest. So here what we will be doing is we will be using the concept of relative velocity. Why do we use first of all the concept of relative velocity? In relative velocity, we keep one body at rest, and with respect to that body we analyze how the other body is moving. Instead of applying the equations for both the bodies, we keep one body at rest, and with respect to that body we analyze how the other body is moving. So in this problem what I will do, I'll keep one at rest, and with respect to one I will see how this body 2 is moving. You can keep 2 at rest also, it doesn't matter. So here what we will be doing, we will be keeping 1 at rest, and with respect to 1 we will calculate how 2 is moving. That means what I have to do, I have to calculate velocity of 2 as seen by 1. As seen by 1. That is V21, which is nothing but V2 minus V1. I hope everyone understands. Velocity of 2 as seen by 1 means this body 1 will be basically kept at rest, and with respect to that body we will see how 2 is moving. Now V21. V21 is nothing but V2 vector minus V1 vector. So how do we write V2 minus V1? We know minus can be written as extension of addition plus of negative V1. And then here we will be taking negative of V1. V2 is up. So we should not do anything for V2. V2 will be kept as it is. And we have to take negative of V1. V1 is to the left towards west. So negative of V1 will be to the right minus V1. And what we have to do, we have to add them. So you can add them either using triangle law or parallelogram law. So I'll complete the parallelogram. The diagonal is going to represent the resultant. What is this? This is V2 vector plus negative of V1 vector, which is V21 vector. And let me find out what is the value of that. This value is 10. V1 is 10, minus of V1 is also 10, and V2 is also 10. So if I use the resultant formula, or if I use the Pythagoras theorem, so this V21 value will be equal to a root of 10 square plus 10 square. If this is 10, obviously this side is also 10, isn't it? So root of 10 square plus 10 square, which is nothing but 10 root 2. Let me find the value. We will see how this will be used later. 10 root 2, this is one thing, magnitude of 2, velocity of 2 as seen by 1. And then this unit is kilometers per hour. And let me also find out this angle made by the resultant V21 with the base. So if I call this angle as alpha, let me find out tan alpha. Tan alpha is nothing but 10 by 10. This implies that tan alpha is equal to 1. Therefore, alpha is equal to 45 degrees. So we have done this work. We have calculated velocity of 2 as seen by 1, how 2 is moving with respect to 1. We also calculated the magnitude of that V21. We also calculated the direction. Okay. It means now you just see, it means if you keep 1 at rest, velocity of 2 as seen by 1, if you keep 1 at rest, isn't it? Velocity of 2 as seen by 1 is in this direction. That means if you have kept 1 at rest, 2 will be moving in this direction with respect to 1. this direction, isn't it? Velocity of 2 as seen by 1. So 2 will be moving in this direction, keeping 1 at rest. That's not the original scenario, but we will analyze the problem like this by keeping 1 at rest, so that we have to apply equation only for one body. So velocity of 2 as seen by 1 will be in this direction. So let me draw that. Velocity of 2 as seen by 1 will be in this direction. 2 will be moving in this direction. 2 will be moving in this direction. If I keep whom at rest, if I keep 1 at rest, if I keep 1 at rest, velocity of 2 as seen by 1 will be in this direction. So now, so 2 is moving in this direction. So if 2 reaches here, this will be the shortest distance. Drop a perpendicular from 1 to 2. When 2 reaches here, that is when you have dropped a perpendicular from 1 onto the motion of 2, correct? That is the shortest distance, isn't it? Shortest distance, how do you find? By dropping a perpendicular. You drop a perpendicular from 1 onto 2. 2 is actually moving in this direction as seen by 1. So keeping 1 at rest, 2 is moving in this direction. So I have just dropped a perpendicular from 1 to 2. This will be the shortest distance, isn't it? This will be the shortest distance. So we can find the shortest distance by applying some trigonometry. By applying some trigonometry, we can find it. Now, this is 45 degree. Alpha is 45 degree, isn't it? This is the direction of V21. This is the direction of V21. So this is given as 45. Alpha is 45. So if this is 45 degree, this will also be 45 degree. Did you understand? So you find out this distance. Let me call this as, say, some A and this as 2. So what is the distance A2? You can apply some trigonometry. You can apply sine function or cos function. So if I use cos 45 degree, cos 45 degree is going to be adjacent. Adjacent is nothing but the distance A2 divided by hypotenuse. Hypotenuse is nothing but 100 kilometer. Cos 45 degree is 1 by root 2. So A2 is going to be equal to 100 into cos 45 degree. Cos 45 degree is 1 by root 2. So many kilometer. This is the distance A2. This is the distance A2. Even this distance 1, 2 also will be 100 sine 45, and that is also going to be 100 by root 2, and that's the shortest distance. But the question here is, we need to find the time after which the distance becomes shortest. So here you have to be very careful. See, when is the shortest distance achieved? When is the shortest distance achieved? When the particle, when it is here, correct? When the second body is starting at A, and when it has reached 2, that is the time, correct, after which the distance has become shortest, isn't it? 1, 2 is nothing but the shortest distance I can call. This is nothing but the shortest distance. So 2 has to reach from where 2 has to reach? 2 has to reach from A to 2. Then only the distance will become shortest, or we need to calculate the time after which the distance becomes shortest. So here in this direction, what is the velocity? In that direction, the velocity is nothing but V21, which is 10 root 2, and the distance is how much? The distance is nothing but 100 by root 2 kilometer. So we can easily use the equation. We know the distance in that direction and we know velocity in that direction. So we can use velocity equal to displacement by time. But you should be very careful that if you are using this equation, that velocity and displacement should be in the same direction. Very, very important. Velocity and displacement should be in the same direction. That's why I found velocity in the direction of the shortest distance, isn't it? That is a V21 I found. And in that direction, I'm finding the distance 100 by root 2 kilometer. Why did I find that component A2? That is because if I'm using the equation velocity equal to displacement by time, then velocity and displacement should be in the same direction. That's why I found out that distance A2. So time will be equal to distance by velocity. Distance is how much? Distance is nothing but 100 upon root 2 divided by velocity. What is the velocity? Velocity is nothing but 10 root 2. So 10 tens are 100, and root 2 into root 2 is going to be 2. So 10 divided by 2, and that is going to be 5. 5, and it is in R, because all the values are in kilometers per hour and we have not converted into meters per second. So option will be 5 hours.